So I'm just going to start talking. This is a session on building user interfaces with React. And what we're going to talk about, once we get some slides and some projection up to do some coding, is we're going to talk about React's component-based model and talk about the motif in the React framework in terms of how we approach and build stuff from a component-based point of view. So when we think of React, it's different than other frameworks in that we take a component-based approach to how we view and assemble our application. So instead of thinking of merging templates in like you would with Angular or using ng template, yay, we have slides. What we prefer to do is we prefer to think of our application as two basic things, components and state. And we'll get into that as we go through some of the slides here. Right? React is a UI-only library, so what we have to do is we have to add in a couple of extra things to give us the tools that we need to build a complete single-page front-end web application. It is developed at Facebook, but there are lots and lots of people use it. It's the second most popular framework today behind Angular.js. Now, in terms of React itself, we'll talk about a few core things quickly, and then we'll get on and do some live coding and build a React application. So one of the things that React brought to the mainstream is this ability to do isomorphic, or what is now called universal rendering. So that means when you write a React application in JavaScript, you have two different options in terms of where you actually run that code. You can run it on the server, or you can run it on the browser, or you can mix and match. So that means if you have a React component, the ability to do isomorphic rendering means that you can actually take that code and say, I want everything to run on the front end in the browser, or I want everything to run on the server, or maybe you have a search widget or search component that's really heavy and is data intensive. You can say, well, you know what, let's just render just the search component on the server and send that up pre-rendered into the running React application in the browser and let it plug in that pre-rendered component. So this is the, again, ability to do isomorphic rendering, run your JavaScript React code either in the browser, where it would normally run, or on the server. It gives us the ability to do great performance management and gives us developers the added bonus of having a fair amount of flexibility. Right. So that's not the main reason React is fast. Obviously, doing isomorphic rendering on the server allows us to do low-level performance management, but React also mainstreams something called the virtual DOM. So the virtual DOM in React gives us the ability to do smart diffing of things which are in the DOM and also allows us to batch DOM updates. Right? This is why when we look at performance measurements from React versus other frameworks, it's very, very fast. And in fact, the virtual DOM is such a popular thing that almost every major framework is incorporating it into its code, basically. Right? So if you're using Angular 1, you cannot use any kind of virtual DOM technology, but if you're looking at Angular 2, for example, or the latest version of Ember, they all incorporate the virtual DOM, which allows us to get this super fast rendering inside the browser. Right? So we'll skip that slide for now. And when we think of the typical browser update and why the virtual DOM works so well, is that the browser typically has three major phases from the time that you give it an HTML fragment or an entire page with the CSS and everything, and it actually shows it to the user. So the first is the browser has to parse the markup in CSS, and then has to create a render tree or native DOM object from that. And once it has that render tree, it has to figure out how to position it, i.e. how it flows into the page, and then it has to actually show it or paint it. And of course, when you do an in-situ update, you're going to do a reflow and repaint. Right? So these are the three major steps in any web browser update or whenever a web browser has to make some kind of change to show to the user. Now, if you do that last step a lot, that's when you see slowness. So this is what we want to avoid, is doing a lot of reflows and repaints. Parsing the markup in CSS, creating a render tree, those two operations are typically very fast. It's the last one that the user will perceive as slowness. So this is what we want to avoid doing. Right? Now, what causes a reflow and repaint? Anytime you do a DOM update, you hide a DOM node, move or animate a DOM, or make any style changes, you're going to trigger those 3 steps, but specifically the reflow and repaint. Right? So we want to avoid doing those as much as possible. And this is where the virtual DOM in React kicks in. The virtual DOM manages the DOM state. When you ask React to make changes, you add React components into the view, or you remove React components from the view. The virtual DOM does smart diffing so that it reduces the number of changes that need to be applied. And again, when you add or remove React components from the view, it also will go and see, can I batch these things together? So if you effect a change and you propagate the change from the top to some child elements, it will say these 3 elements needed to change. I'm going to make those 3 changes all at the same time. So it batches the DOM updates, right? This is why the DOM is, or the virtual DOM, adds a great amount of front-end performance. It batches the DOM updates and does smart diffing to only apply the changes which are needed. Now, as a React developer, you don't have to do anything special to use the virtual DOM. It's just there. All you have to do is you have to follow the React component model and code within the framework. Right? You don't have to do anything special. There's no configuration that you have to do around the virtual DOM. It's just there, and it's just on. So let's get into some React basics for a few minutes. The heart of React are React components. So when we look at what a React component is composed of, it's the basic building block, and it uses a syntax called JSX, or JavaScript XML syntax. And a very simple example of this is on this slide. So you can see that we have something that looks like JavaScript, React.render component, and then document.getElementById. But there's some kind of HTML-like tag in there, right? So it's an H1 tag. And this is what JSX is. It's essentially mixes in a little bit of markup into your JavaScript so that all of your component and component logic and component definition are contained, encapsulated in one place inside of a React component. So let's get off the slides for a bit, and let's actually talk about how we build these components. Right? You can see that JSX is HTML-like, but it does differ a little bit. For example, when you're writing JSX, and say we have this H1, let's actually just drop into some code. Go find our project. Yeah, okay. And let's just open up this first sample. Right. So hopefully that's big enough to read. Wow, it's huge. Okay, we make it a little smaller. Right. So when we look at this specific React application, what we want to do when we create components is we want to say, create a new component called Lunch App in this case that extends React.component. So this is using ES6 style JavaScript rather than ES5. But as you can see in this example, in the return block, we have JavaScript up here, and then we say, create a div, create an H1, and then use this other thing called a menu panel, which is a second component that we've declared in this file. Again, menu panel, our React component, extends React.component, and inside of here, you can see that, again, we have some JSX. Right? Now, there's some small differences in the JSX in terms of what we have to do to make sure that it's correct. For example, we can't say we want this to have a class like so. We can't say that because class, as you know, is a keyword in ES6. So instead, what we have to do is we have to say class name. Right? So there's some small differences like this, but they don't really get in the way when you're writing a React application. Right, so that's just some simple JSX. Now let's go fire this app up from the command line. Okay. And let's get our web browser open, and let's do some live coding around this. You can see that this is, we'll go into the build system if we have a little bit of time later, but let's get our main component up and running. Let's restart everything. Let's make sure this works. Okay. Now we should be good. see if this works now. Okay, so here's our simple application. As you saw before, what we did was we said, let's go get the date. We're going to say hello, and then we're going to show a couple of different things in this application. Okay, and so far, all we're going to do is just show a couple of options for lunch. So the way that we initiate a React application is we say react.dom render this specific component, in this case called hello world, and mount it into this location called document.getElementById root. If we go look at the index.html, you'll see that we are using a build system, specifically Webpack, to take our React application and all its dependencies and put it into a bundle.js, but we have a div called root right here. If we go look at app.js, react.dom.render into the place called root, this top level or root component called hello world. So let's go look at our hello world application. You can see var now date equals this, lunch order app, and if we go into here and make a small change, let's get this web browser next to it here. Okay, we'll try to get our code and everything on the same view. Okay, so we can say lunch order, or let's just change this to say today's lunch at Devoxx. Okay, so we'll go save that, and you can see that we've affected that change into the browser. So one of the great things about React and the tooling is that we have this ability to have this live update, right? So you saw that we went and just changed something, and we hit save, and it automatically shows up in the browser, right? So this makes for great developer velocity. Okay? But let's get back to our component. So we have class hello world, extends React component. Our render is the actual definition of our view. And we have some JSX in here. And we're going to use a subcomponent called lunch options panel. That's defined down here. And we're going to say, we need to show what today's lunch is going to be. So let's pass that in as some initial data, or what we call properties in React. So we'll say let lunch options equal these three things. And then when we go and do the initial render, we say render the hello world component, give it an attribute or property, which is this lunch option. So essentially what we're doing is we're passing in this array into this hello world component, which will be over here. And then we need to pass that down further into the subcomponent. So we'll say this dot props dot lunch options. And again, that lunch options is here. We pass it as an attribute to the top level or root component. So we go to hello world, it's going to be called lunch options. We access that by saying this dot props, and then we're going to pass this now again as a property into this subcomponent called lunch options, and now I'm just renamed it LO so that it's a little bit more clear what's going on. And now in this subcomponent we say this dot props dot LO or lunch options, which is this guy right here. And we're going to say map over that array, because if you remember, that thing was an array like so of 3 items. Map over or iterate over that array and return this JSX that represents what those 3 lunch options are. Right? So you can see that we're putting this in LI. We could change this to a UL. Right? I don't think that'll make a difference, but right? So you can see that we essentially are iterating over those 3 items and showing them into the view like so. Right? And the way that this happens is we say the lunch options formatted. Right? Today's date is this. We say now.string. And then we use this variable called lunch options formatted down here. And we use curly braces to say that this is some code or some JSX we're going to inject from a variable into this application. Right? So this is basic component. So we have lunch options panel that's used inside of the hello world component, and we have some markup around it to show what our options are. So we can go and create some components from this and other things as needed. All right, so let's talk a little bit more about these properties. Right, so properties are the way that we pass data around from one place to another. Now, we can also use something called state. Every React component has state. And what state does is it essentially represents the data that's supposed to be in the component and the structure of the component. In this case, we're not using state. But let's go to another example and have a look at what that state actually looks like. Okay? So if we go into here, let's just clear up some of these errors real quick so this ESLinter doesn't give us trouble. So let's go find where we're using state in this second example. Right? Again, we talked about how the properties are passed in to give some initial values, to set some initial state, if you will, in our application. Right? And you can see, again, we're using the lunch options panel. Now we have the proper lunch app here. And if we go look at the state of this example, let's actually fire this up. Okay, let's just double check that this works properly. And we should be able to see our application looking slightly better inside of our thing. Okay, so let's go and interleave this so that we get a nice setup for doing some coding. Right, so what's going to happen in this specific example is we're going to use state and pass it down into a subcomponent. So you can see that when I click these three things, the subcomponent here says that you picked the specific meal for lunch. Right, so how is this happening in this example? We passed in the properties as lunch choices. That goes into our lunch option panel like you saw before, and we get iterate over the lunch data, we show it, and whenever the user clicks one of those things, we go and pass in the selected lunch to a subpanel called selected lunch panel. Okay? So how is this actually happening? Well, what does the state and the properties have to do with each other? Right? So again, we start here with lunch choices. That goes to our top-level component, which is called lunch app. We pass it to a subcomponent called lunch options panel. This .props.lunch choices gets put into this thing called lunch data. And then, again, we say this .props lunch data, map over it, and create a label that basically shows it over here. But when somebody clicks on it, we have this thing called a click handler, which is just a function. And what that does is when we click on one of these items, like so, we say, okay, someone's clicked on one of those things, so now let's go set the state of this component. And we say this.setState, set the selected lunch to be essentially the text content that is within these three buttons or labels. Okay? So we pass the properties in to initialize some data into our component. And now when the user does something with our application, we go and set the state to do the appropriate thing. In this case, what we're going to do is we're going to say set the state for selected lunch to be whatever the user picked. And then we're going to use this.state.selectedLunch. This is the state that we set, again, up here in our handle click, this.setState, set the selected lunch to be this thing, and pass it into a subcomponent called selected lunch panel, which is this guy right here. So we're taking the state in this parent component and passing it down into a subcomponent called selected lunch panel. And then if we scroll down here, you'll see that we use this.props.selectedLunch. So we set the state in a parent component, and then we're passing that state down as a property into a subcomponent so that it can be shown to the user. Okay? So what's happening here is when we set the state, let's go reload this actually, right? If we keep an eye on this, right, I'm just going to reload this. You can see that right now, our app says that nothing has been selected. Okay? So where's that nothing selected coming from? Again, we're using the state of our application to go and hold this data that we want to show to the user. So what we do in our component called Lunch Options Panel, you can see it's a React component, is we say this.state in the constructor, and the constructor is an ES6 thing, a keyword, to go and basically work with objects in ES6. So we say in the constructor of this component, set the initial state to be selected lunch, nothing selected. So we're setting the initial state to be some variable. In this case, we want to say nothing's been selected so far, right? So you can see that's where that nothing selected comes from. However, when we click on one of these items, we're changing the state, because again, we say on click for that specific option, hit the click handler, which is this guy right here, and set the state. We set the state of that selected lunch, and then we pass it down again to a subcomponent. And that subcomponent essentially receives a property, which is the state. But how does React know that when we click on this, we need to go and change the subcomponent? So what's happening here is that whenever we do a call to set state, React says, oh, you want me to change the state of the application. That means you either want to change some of the data that's there that we show into the view as text or something like that, or we need to change the structure of the subcomponents of this component and all the subcomponents. So whenever you do a set state in React, what you're doing is you're saying, React, go and refresh this component and all the subcomponents that are contained underneath it. Okay? So this is how we affect change in a React application. One thing that we could do is, say instead of just setting the state from here, what we could do is we could make an AJAX or network call and get data and set some state. Okay? So we could say the user clicked this search button. So let's go in the click handler, make a call to our server, get the search results as JSON, and then we'll set those search results as state in our application at the appropriate place. And once we've set that state with this new search data, it will re-render or refresh that component and all the subcomponents underneath it to show whatever operation the user wanted to do. Okay? All right, so that's a quick discussion on state. The other thing that React has is it has specific hooks for working with components at different points in time. So, for example, we have component will mount, component did mount, component is going to receive some properties, component is about to update, component did update, or the component will unmount. So these are places that we can write some code to hook in to add functionality, right? Obviously, you saw how we got initial functionality by putting that into the constructor and setting the state to be like so. But obviously, as we go and do stuff, there'll be times when, before we mount a component, we may want to go and grab some data or go get some settings or something like that and affect how the component will actually look. Right? So if we come into here and do inspect on this, and this is going to be tricky on a small screen, but we'll try this. All right, so let's clear this. And now, remember what we're doing when the user clicks one of these options here is we hit this click handler and we set the state of this component and the subcomponents. So we have these console.logs here to see what actually happens as we click these. So let's do this. All right, so keep an eye on down here. So when I click this, you'll see that we get the lunch options panel, which is the thing that we clicked on at the top. Component will update. Here's the data that was there. And now the subpanel, or the selected lunch panel, which is contained within the lunch options panel, also gets updated. So you can see it says the component is about to receive some props. Component will update. Component has updated, and this is the data that it updated with. And finally, we'll walk back up the tree and say the parent component, in this case, the lunch options panel, component did update. Okay? So you can see what we've done here is we've affected a change in a parent component, and it went and said, here's some properties to the subcomponent. The React framework, again, takes care of all this, and we can use these specific things that we see here, or these lifecycle hooks, to do cleanup or initialization or whatever we need to do in our application. Okay? So the other thing that you may have noticed is that this looks a lot better than the last application, the last demo we did. And the reason for that is in this case, what we're doing is we're using the React Bootstrap component library. And what this component library is someone has taken the Bootstrap CSS library and created real React components from it. So we say import Bootstrap from this React Bootstrap library, and then we want to use a couple of different things. We want to use the Bootstrap label, the Bootstrap input button, the Bootstrap panel, and you can see this is how we go and grab those specific things. And we just use them as standard markup then inside of our application. So for example, if we go look at the React Bootstrap label component that's provided for us by this library, you can see this is where we use it to go and create this nice looking label. And of course, the panel that we have here, for example, this guy right here, is panel, header, etc. So this is essentially, again, the Bootstrap library that has been converted into real React components. Right, so we can very quickly write a nice looking React application by using off-the-shelf React components and write our own components along with or on top of that by customizing it. Okay? So looked at the component lifecycle, we've looked at some component basics, we've talked about state, we've talked about properties, and honestly, this is the extent to which you need to know React to get started with it. It's very, very easy to get started. There are just a few things that you need to know. We've talked about all those in, 15 or 20 minutes, right? And this is one of the reasons React is great. It's a very simple component-based model that is easy to get started with and easy to build a nice application on top of. So let's get back to our slides and talk about a few other things. So you don't have to write JSX. You can also use this React.dom library that's built into React to create components purely in JavaScript, right? But typically what people do is they don't do it like that. They write JSX components like you saw a minute ago when we were writing some code, right? And we've talked about a couple of these things. So let's just skip ahead a bit and get to the appropriate place. So next thing I want to talk about is we talked about state. We've talked about how React components use properties to pass data down and how the state of a component determines, the stuff that's inside of it and the structure. But when we think of a React application, what we do is we model the application like a tree. So we have a top-level container, right? In our specific example, it was called just Launch App or something like that. And our top-level component contains subcomponents, which then contain their own subcomponents, and so. Okay? So a React application is essentially a component tree that has data and that has state. And the great thing about that is that when we want to model something or when we want to create something, what we do is we think of everything in terms of this tree. What do we need to do to create this table panel with all the stuff underneath it? We're going to add these components. They're going to have very specific state that shows the user what they requested. And when we need to make an update, we make an update at the appropriate place. So say we wanted to update this panel and its subpanels. What we could do is we could say, go and change the state of this, which may still have these subcomponents underneath it, may have other subcomponents, and the data. So in a React application, we think in terms of a state tree that represents the data that the user is looking at and also the structure of the application. Okay? So that's key in terms of how we work in the React world and how we model the universe. And in a lot of ways, it's a much simpler way of doing web development. We basically only have to keep a couple of things in our brain. What components do we need to create? And where does the component live in this state tree? And when we want to make a change, we just go change the state. Right? We'll talk in a few minutes about one-way data flow. So you know how in Angular and other frameworks we have something called two-way data binding. React does not do two-way data binding. Instead, what we do is, again, we think of everything in terms of a tree and state. So we say, okay, we need to go change the state of our application. So specifically, we need to change something in this map panel right here. Let's go change the state of the map panel, and that will go and do the appropriate thing in terms of the components for the rest of the application or the rest of the subcomponents that live there. Right? So what we do as developers is we say, this is what the application should look like right now. The users click this, or they've entered something into a search bar and they've hit search. We'll go get the search results and say, React, this is what the application looks like now. This is the state, the data, and the component structure that you should have now. The user's done something else. React, this is what you should go and change now. So we basically start from the top and we say, go and change something. Or this is what the user wanted changed. The user clicked on another button to submit an order. React, this is what the state of the app looks like. So it's one-way data flow. We basically start from the top and we flow the data down into the actual application. And honestly, because of the virtual DOM, you can even drop in brand new data at the very top here and re-render the entire tree, and it will still be super, super fast. You don't have to worry about it being slow because the virtual DOM takes care of that. And it's really, really fast. Even if you have hundreds of components that are materialized in the view, re-rendering it from the top or resetting the state from the top and refreshing the entire tree takes very little time because, again, the virtual DOM keeps track of what's already there, what changes need to happen, et cetera, et cetera. Okay? So let's talk about a few other things. We've done the demo already. We talked about the lifecycle components have state. Doing a this.set state causes a refresh at that point in the component tree. Right? Also, events are intercepted in wrap. So whenever a user does something or they click on something, there's something called a synthetic event, which is a cross-browser wrapper around events. But again, you don't really have to worry about any of this. This is all just taken care of by the framework. If you remember the code that we wrote to trap an event, we said when the user on this H3 does an on-click, right, so you can see we're just using very specific nomenclature here to say on-click, go hit this click handler, which is just an alias for this.handleClick, which was, if you remember, this guy again, which went and changed the state. But you see what we did here is we don't necessarily just go and re-render some new components or whatever. We think in terms of the state or the data of the application. The users click this. Now we need to update the state in the appropriate way. In this case, the appropriate way was to change our state to set the selected lunch to what the user actually selected. Okay? But you can see for our click handler itself, it looks just like standard JavaScript, HTML type of coding. All right, so let's get back to our discussion. And we're not going to do this example, but let's have a look at a couple of other things. Right, so we discussed earlier about isomorphic rendering. So what we can do in our application is we can say, you know what, let's render this component on the server rather than rendering it in the browser. Or one of the popular things to do today is when we first go and initialize our React application, we'll want to do isomorphic rendering of the entire application and do it on the server and send up to the React running in the browser a pre-rendered, ready-to-go view. And we can do something like this. We can say React, oops, wrong button. We can say React render component to string. This is our top-level component. This is the data. So now we have this as markup, i.e. as a big string that represents our React component. Let's inject this into a standard HTML template, and we also need to send the state of this pre-rendered component. In this case, this component is our entire application. Let's send everything up. So once React initializes in the browser, it'll say, oh, you've sent me a pre-rendered React application, so I don't have to go and walk the tree and create all the components and get everything set up. I can basically take this render to string that you've done on the server, and I can just directly plug it in to the browser, and it will become a live React application. Right? So this is kind of the isomorphic rendering part of it, or what we also call today universal rendering in React. All right, so talk about a few more things in terms of overall architecture. I think we've covered all of the basics in terms of how we create components, how we handle changes, how we set state, how we pass properties down at the top, and then from component to subcomponent. So all the basics have been covered. Let's talk a little bit about the kind of the architectural style around this. And if you remember, set state invokes render for components and all subcomponents, and that is not slow because of the virtual DOM, which takes care of all that stuff for us. It takes care of the smart diffing and the batch DOM updates, and all the virtual DOM stuff is happening in JavaScript objects, which are lightweight and very, very fast. Okay? So let's talk for a few minutes about some topics around React. Now, one thing in React that you cannot do is you cannot go underneath the React component and directly manipulate HTML, because you'll get in trouble if you do that. And in fact, there is a method that will allow you to go and directly monkey with the HTML in the DOM, or whatever, anything in the DOM. The method is actually called dangerously change inner HTML, right? That's not a joke. That's actually what it's called. So we have to be careful that we don't do that. But again, if you're writing standard React code, you never really need to go underneath the React framework and monkey with something inside of the DOM itself. You just write a component that does that for you. So one of the challenges with React, because of the virtual DOM and the fact that you're not supposed to directly monkey with something in the DOM, is how do you do animations in React? So there's very specific things that allow you to do animations, but you can't just go and say, let's go animate this. What you have to do is you have to use something called a React animation group. And what that does is you say, around these components, when things change, apply this CSS-style animation or transition group, or use a div-based animation. So there are very specific ways that you can do this. Again, it's called React and animation groups or React transition groups. So that's something to be aware of as you're writing React, because obviously you will want to have some animation in your application to give it nice look and feel and UX, etc. Right? So there are also libraries which have off-the-shelf libraries which allow you to do some nice animations without you having to really write them yourself. You just plug them in and they'll do the animation that you specify. Right? And again, when we're updating the view, we think of everything in terms of a state tree. We say, okay, React, here's the new state of the application. Make the application look like the data that I just gave you. Right? So we let React do that and work with the tree as appropriate. So in terms of routing in React, how do we do that? By routing, what we mean is when a user comes to your application and they click on today's lunch, we want the URI to change from www.devoxx.pl/home to /lunch or to /schedule or whatever, right? We want the URI to actually change so that the user knows as they're navigating through our application where they are. And we could do that ourselves, but there's a good library called React Router, surprisingly, that allows you to do that. And what you do is you basically define some routes, and you say, okay, this is what the routes should look like. And as the user goes from view to view, and React swaps in a panel or swaps in part of the view and changes the view that's contained within, it can go and update the URI. So let's actually have a quick look at that, just to give you an idea of what it looks like, and then we'll move on to some closing thoughts real quick. All right. So here's what the routing looks like. So we're using React Router here, and you can see we have declared the router. This is the default path. The index route is also this guy, and here's a support and contact route, et cetera, et cetera. Okay? So what we do is we basically declare this, and these guys right here, as you can see, points to components. So if we go look at this file, you'll see that there'll be a support component in here. So when the user clicks on a link that takes them to the support page, React swaps out the whatever view it's on and puts in this specific component that represents whatever the support is, or the contact, or the main one, which is our lunch choices, options panel, or whatever. Okay? So the other thing is that while Angular and Ember have taken a imperative, object-oriented approach to building single-page web applications, React is moving in the direction of using more functional programming in JavaScript to construct its overall application kind of motif. Right? You saw that we use classes, right? So if we go back here, you see that we're using classes in our application. So we are doing some object-oriented programming here. Right? So here's a class keyword. Again, that's an ES6 construct. But if we go look at the way that people are writing code with libraries that sit on top of React to give you the tools and functionality you need to build a proper application, there's more of a functional programming approach to that. So this can be a little bit daunting for people. So it's not a good idea to necessarily jump into using a library that sits on top of React like Reflux or Fluxery or Redux or MobX or whatever. Okay? But almost all of them adhere to what we talked about earlier, which is a one-way data flow type of model. And if we visualize what that looks like, right, this is how modern React applications are architecturally built. We have our view layer down here, which are our React components. When the user clicks something or something needs to change, we go to the top. We say we have a metaphor for an action. Let's say the action is go get search results. It'll go hit our backend API. Our data comes back. We'll go and flow that data down into the view. We may have a dispatcher and a store. Right? The user does something else. We go to the top. We reset the state, or we set the state to be what is appropriate for that action, and we flow that data and structure down. Right? And this is what's known as the Flux pattern for React. And there are a bunch of libraries that implement this. I mentioned a couple of them before, like Reflux and Fluxery, Redux, MobX. They use this kind of style of programming. This is called one-way data flow. All right, so we're near the end of time. Just some closing thoughts real quick. All right, we talked a little bit about Flux. What I will say is if you're new to React, don't jump into the deep end of the pool and try to learn React as well as learning something like Redux or Reflux or any of these things that sit on top of it. The way we approached it is we built a basic prototype application just using React itself. And it was super simple. We were able to get off the ground really quickly. We got familiar with the framework pretty fast. And as our application grew in size, we're like, this is probably a good point in time to refactor it and add in a library to be able to manage the larger React application we have today. So what I tell folks is if you're new to React, don't try to learn React and Flux or React with a Flux library like Redux or MobX or Reflux. Just learn React first. Build a simple prototype with just React. And then if you feel it's appropriate, your application has gotten large, and you need, like, wow, we have so many components, and I'm having trouble figuring out exactly what the state should look like and where the state should go, and et cetera, right? You'll eventually feel those things as your application gets larger. That's when it may be a good time to go and incorporate a library for React that sits on top, like MobX or Redux or something like that. All right. So we're going to end now because you always get really bad reviews if you keep people from their lunch, surprisingly, right? I'll be happy to entertain some questions up front afterwards. All right, so thank you for coming.